right, so we're looking at proofs, and we're looking at similar proofs. So in terms of our options right now, we have either SSS, SAS, or AA to choose from. So looking here, I only have one set of angles, so this one's out. I only have two sets of sides because I don't have this one, so this one's out. So since I have an angle in between two sides, just like this, the angle's in between two sides, that's really my only option to do. So in terms of things that are given, I have the angle B, the measure of angle B is equal to the measure of angle E. And that was marked. So we knew that that was true because it was given. And then I need to set up ratios. It's very tempting to say, oh, the 3's are both on the right-hand side, so choose those. It's also tempting to say, oh, they're both 3's, so choose those. But here's the thing. If you compare these two, this one is the smaller of the two. And if you compare these two, this one here is the smaller of the two. So the truth is that the 3 should go with the 2 if you're setting up the ones that are corresponding to each other. So we're corresponding ratios. Then I would set up 4.5 is to 3, which, awesome, is also 1.5. So I now have an angle in between two sides, which is enough information to prove similar. I do need to be careful in setting these things up. So the B's go together with the E's. Remember, this one went along the long side. This one went along the long side. So C has to go with D. And then A, I ran out of room, goes with F. You could have something different, but you do need to make sure that the D and the C go together, the B and the E go together, and the A and the F go together. Now that I know that they're similar, now I get to solve for my last side. So now I can set up 3 is to 2 as 4 is to DF. And my reason would be similar triangles allow me to use that because I get ratios that are equal to each other. So I have what? 4 times 2 and then divide by 3. So I get, that didn't work out, 3, oh, I messed that up. This 3 is to this 2 as DF is to 4. There we go. That should work out better, which then gives us what 12 divided by 2 is 6. DF equals 6. All right, proof number 2. We'll do 2 at a time here. For these here, I can set up some ratios. So 4 goes with X, which means I don't get to use that. Again, I have 2 sets of sides, but I don't have any more than one angle. So angle's out, SSS is out. So again, SAS is my only option. Now, I do not get to say angle C equals angle C, because then I want to make sure I'm talking about the left one equals the right one, 2 separate ones. So I can say ACB, and I can say DCE. But again, I do not get to say C equals C because that's confusing. Which one are you actually talking about? The reason for that one is vertical angles are congruent to each other. Hopefully we know that at this point. Now in terms of setup, it's tempting to put the top ones on the top or compare those two because they're both on the top. But this one is the smaller of these two and this one is the smaller of these two. So 2 really should go with 4 and 3 really should go with 6. And that means that they are similar. And now that means I have these sides, and this angle in between it. So again, I have SAS, triangle similarity, and I'm going to go ahead and just willy-nilly write ABC, but then I have to be careful. So this one goes with this one because it's kind of along this side of the circle one. B goes with the D, and then obviously C goes with itself. Now that I have that, I can say 3 is to 6 as 4 is to x, so 3 is to 6 as 4 is to x. And I get to do that because similar triangles give us equal ratios. And then x will equal 8 when I'm done.